Good morning, everybody, and a very belated Happy New Year, maybe Happy Semester. So, I am very proud to be here, and there is a theme of my talk, the light at the end of tunnel. In fact, did not want to come here because I had some other engagement this time. I was attending a conference in TIFR. It is still on. So initially I said no twice. Then I agreed, but by seeing the very sincerity and affection of the organizers. So I am very thankful to the organizers, and I am particularly thankful to Miss Vani for her kind introduction. And if I would not have come here, there would have been a lingering sense of guilt. So that is gone now. So that is also a light at the end of the tunnel. And this wonder, I am feeling very nice in this wonderful campus. And this is my second visit. I came here in 2014 August. There was for some lecture. It was a Chawla Space Center is there. They had organized Professor Samuel Sengupta Memorial Lecture. He died young. He was a professor in your institute. And that time I interacted with many students, but they were mostly interested in astrophysics and space science. There is focused. So I mostly that time spoke about my work, and it was slightly technical. But now I find the audience is diversified from school students to various maybe freshers who may not have much of background in astrophysics. So I'll be talking about my work, give a little flavor of some of the things I have done, but essentially it will be a chat, kind of chat. And my theme would be that I would see that kind of difficulties one can face in life, and it is possible to overcome them. And despite that thing, many difficulties one have, and one can see a bright end also. There is often, if you are very sincere and capable, there is a light at the end of the tunnel. Maybe I give a little bit more introduction about myself. So I joined Bhabha Atomic Research Centre, which is a premier R&D institute. But there the emphasis is mostly on technological things, technology development, very important things it does. Nuclear research, all these reactors, maintenance, their research, and all spectrum of applied research. And earlier when I joined, it was doing very well in basic science also, particularly in nuclear physics, because we had the accelerator and many of the basic facilities what BRC has. Still India, very few universities can have that kind of facilities. Biology labs are excellent. Our chemistry labs, we have the best world-class facilities many cases. And but we did not, there was no astrophysics in BRC. Astrophysics one lab was there far away in Gulmarg and Srinagar. So what happened, I wanted to do some basic science, always being a Bengali. And but it was very difficult. I was third in my batch, 1979 batch training school. But I was told that there is no placement, even for nuclear physics, there is no chance. So, and I wanted to do actually particle physics. There is no chance, and you have to do some experimental thing and project things. So I said nothing doing. Then somebody told me there is a vacancy in Kashmir, far away Kashmir, and some placement is there, some small lab is there, nuclear research lab. You have to, and the last boy in our class actually he opted for that. He did not have any option. He had to go to Kashmir. So I swapped with things. Somebody told me that it is they do some cosmic ray. You may have some chance of doing basic research there. So I swapped with him and I ventured for Kashmir. And that was my first venture. Actually, I hail from a very lower middle class family. So when I came to Bombay, that was my first trip outside West Bengal. And that time also the BRC made the payment. We traveled by third class ticket, and I remember the fare 65 rupees by Mumbai Mill. BRC paid it because I could not afford 65 rupees to come on my own. And when I went to Kashmir, I did not tell my family. So they do not have much idea of Kashmir. Neither did I have. So I read that Jammu and Kashmir are twin capital of the state, and maybe they are twin cities like Hyderabad, Secunderabad. So there was a train station, Jammu station. So I reached there, and I thought I would take an auto and reach Kashmir, but it was 300 kilometers. I did not know that time, and mountain roads. So anyway, I reached there, and I faced lot of difficulties. Kashmir was cut off, mostly no electricity in winter, and lot of difficulties. I would not talk much of the difficulties, but difficulties can give you some funny things also. Maybe I will share few of the anecdotes. So I didn't know any cooking, anything, but eventually I was forced to learn something, a little bit of cooking. And our laboratory was finally in a village called Zakura, which is near Hazratbal, on the famous shrine. And it was 14 kilometers away from the city center, Lal Chowk. So at weekend we had to go to the Lal Chowk to fetch our provisions. There was no good provision shop in between. And mostly we would get provision not only for a week, sometimes for a month also. And being Bengali, my Hindi was not up to date, and there would be some problems in telling an incident. So once I went to Lal Chowk and bought from a big provision shop, they give me this, give me that. And I didn't check the price list also. That I don't do even now. So when I came home, and I had ordered 1 kg of chida, that is pressed rice. So that can be stored for a long time, even in winter. So when I wanted to have the chida returning home, I found, my goodness, there is no chida. Instead, there is a big pack of jeera, that is cumin seeds. My goodness, so chida they pronounce as chouda, which I didn't know. I must have told chida, and he has heard jeera. And it would be excessively costly also. So I had to bear with 1 kg of jeera. I distributed it mostly, and it lasted for 1 year. So then I earned my first fame that the Mitra ji ne aisa kiya, jeera laya 1 kilo. So people started talking in the lab. And later there was an even bigger thing. It was around 1983 or so. Again the same provisions of Lal Chowk I went, and I bought some articles, and first time I found that there is a besan, this powdered chana dal is being sold in a packed manner and branded. So I took half a kg of besan and came home. Then in the weekend, some of my colleagues there also, bachelor, came, maybe Sunday, and it was winter. तो उनको चाय पिलाना है, चाय भी बनाया. तो मैंने सोचा, बोला, not only चाय, today आज मैं I will treat you with pakoda also. I have got besan. So I sliced potatoes, and there is kerosene stoves, small kerosene stoves, made tea, and put a kadai and oil, and then making the batter with this besan. But I find that batter is not ready. It is something very sticky and foamy coming out. I tried to fry it, and very funny things happening. It was not besan. That was the first time Nirma was marketed, detergent powder. And Nirma looked exactly yellowish like besan. I was never heard of Nirma, so what I ordered gave me that besan. It was actually Nirma. Then I became quite famous. And even now, after 35 years, some of my old Kashmir Srinagar colleagues, they tell, "Arey Mitra ji ka Nirma ka pakoda to gazab tha." So these kind of difficulties. And one of my theme in my life has been also in a modest way, which I feel that many Indian intellectuals lack, active patriotism. I feel all the people, scientists, everything, German, Japanese, they are very patriotic. They talk in their language. It is not so in Indian context. And I was a cricket fan and cricket buff. In Kashmir, we played a lot of cricket with tennis ball, because many times there won't be much to do. And what happened, I was monitoring all one-day matches. In fact, 1983, India won this first World Cup, and my prediction was that India will win. It was based on many analytical calculations. We had the best combination of all-rounders, starting from Kapil Dev, Roger Binney, and then Mahinder Amarnath, and India won. Nobody would believe. But in 1987, second World Cup, there were problems. So I was keenly watching. The first semi-final was there. In the first semi-final was probably Pakistan versus Australia. And Kashmir, the atmosphere is something, if India loses, they would burst crackers. If Pakistan wins, there would be again crackers. And if Pakistan would beat India, then people would go mad with joy, with many. So and this hurt me very much because a cricket fan and Indian cricket team fan. So in the first semi-final, it so happened Pakistan was favorite, but Pakistan lost. And then I had stored lot of crackers for the forthcoming Diwali. Probably I burst all the crackers in the colony, and it is for the first time such a thing happened. I was told, and the nearby villagers were very angry, and the news spread. Later, I learned that the news even went to nearby regional engineering college, and some people had actually come with a lab gate to beat me. So some people stopped. One was Qasim Ali, who was a Shia, who was he was moderate. He and some others actually stopped. This I was told earlier. People even came to beat me. And since then, afterwards, and my Kashmiri Pandit colleagues said, "You only did it." They live in a state of fear those days. Now nobody lives there. No Pandit lives there. So this is what I do. I can take on the high and mighty, and even tall and mighty. So yesterday, whole day I spent with my friend here, Bihu. He is a fresher in physics, integrated physics MSc. We had a lot of discussions, and I gave him two advices that he is reading a lot of physics. So I told him that if you read to physics, one physics book you must learn. It is Berkeley physics course, so which I benefited a lot. So we read Feynman physics lectures, but Berkeley physics course is more compact and even better than Feynman lectures. Then I requested him whether he plays any. He is a 6 feeter, 6 feet 2 inches. In fact, he has given his photo in Facebook selfie with me. It looks very funny. That is David versus Goliath, 5 feet, 6 feet versus 5 feet. I told him, you play some games, sports. He said no. I suggested he should play cricket maybe sometimes, and I think he will play cricket, or he can have arm wrestling with me at least, if not any game. So in Kashmir we shifted in 1990 and came to Mumbai. And Mumbai also there was no astrophysics. I was spent 2 years in a laser lab, but I cannot give the details. And I have a habit of working on frontline problems. I always make in my way and go for frontline problems. Sometimes they are also little controversial. They becomes. So one of the frontline problems those days, even now, it is the cosmic gamma ray burst. So biggest explosion before that was known to be supernova burst. What happens when a star, say, having a mass of around 8 solar mass to 10 solar mass collapses? So it produces in the core becomes a neutron star, which is extremely compact at the size of around 10 kilometer, but mass more than sun, maybe 1.4, 1.5 solar mass. And when the binding energy is released as supernova burst, and in the supernova burst, the energy emission could be billion times more than sun for a couple of seconds, billion times more. But then astrophysicists learned of another phenomenon called cosmic gamma ray burst. Gamma ray burst could be even much powerful, 1,000 times more powerful than even supernova bursts, and their origin is still not properly understood. So I started working on this thing, and they said maybe in the gamma ray burst the black holes are produced. Now, a concept of black hole even at that time was that black hole from which light nothing can escape. So I thought if nothing can escape and a black hole is formed, then how can gamma ray bursts, which are most luminous objects in the universe, can be correlated with gamma ray with black holes? Maybe black holes are not produced, something else is produced. So I started learning general relativity entirely on my own at the age of 42. So, and I always, when I go, I just do not see the mathematics. I want to go beyond mathematics, whatever inner message is that, and that is my strength. So I correlated the equations various physical way. I found that actually black holes should not form. And I had a lot of difficulty in publishing this result. It was first published in 2002, 2000 December. And then I earned my first kind of maybe little fame. Even BBC radio interview I gave in 2001. And now let me tell you little of technical things. Although there are many school students, they may not be able to understand. I will go through a few slides, because if I have come here to give bit of flavor of what I have done in this area. First slide, please. Okay, I can do. It has come. Okay. So you keep on hearing on black holes from which nothing can escape, not even light. It is the ultimate abyss is there. And on the black hole there is a surface that is called event horizon. That is an imaginary surface. And inside, if anything comes inside it, it cannot escape. And it's just, everything has to come inside to a point which is called a singularity, point infinite density, infinite pressure. Some point is there. Okay. And say they say black hole is ultimate abyss. It is like a waterfall, infinite waterfall. Once you go, you cannot come out. Now, what happens if you go can come out? Something. Say, suppose some astronomer is falling in a black hole. They say, okay. Or you can change. Suppose they say an intrepid astronomer coming. Now, when it is entering the black hole, he is going in the maximum possible velocity. Actually, velocity becomes infinite there. But if velocity becomes infinite, something is falling, it cannot just stay. Either it has to bounce or it has to go somewhere else. So where does it go? This question is in black holes have been discovered for 100 years. It came from Einstein's general relativity exactly 100 years back. And still not clear. Some says he stays there, some says he go to parallel universe, he go to another universe, he emerges from another part of the universe. So that way the picture of black hole is kind of confusing, because first nothing can come out, everything has to die there, and then it is not clear what happens. One enters in one black hole, whether emerges in another black hole. Technically this is called a wormhole. So it is a matter of the subject of utter confusion. And then, okay. And then also at the same time, also you keep on reading everybody, black hole, biggest explosions are with black hole. Biggest bird, black holes are burping. Burping and black holes are vomiting. These two are directly self-contradictory things. A black hole is something from which nothing can emerge. How can they burp? And in most of the headlines, New York Times, everywhere, you will see black holes are burping. And then they won't explain how black holes are burping. It is not explained. First, whenever the black hole or anything is there, like Saturn has ring, there is a disk around it. And from that matter can happen, matter can emerge. But that matter cannot be too fast, and that will be far away, and that their magnetic field is also not very strong. To have a lot of very fast conical outflow called jet, you need lot of strong magnetic field which can, spiral magnetic field which can confine the plasma, and something which can really push things out, which neutron stars can do. The neutron stars, as I told, the supernova burst gives rise to neutron star. They have extremely strong magnetic field. And when they rotate also, they generate a lot of electric field and this kind of helical magnetic field. Neutron stars can do. And more confusion, in 1974, Stephen Hawking told that black holes do radiate. The physics is still not clear. One actually theoreticians do little some mathematics simplified assumptions and some mathematics, and they say interpret how black holes actually can emit radiation. Physics is not clear, but this is considered one of the biggest novelties of theoretical physics. Also, black holes have, they say, have a lot of entropy. Entropy is disorder. What is disorder? In this room, people are sitting here almost quiet. So disorder, degree of disorder is very little. But when everybody will start moving, then disorder will agree, that is the entropy will increase. So if the room is, air is heated, molecules will move violently and entropy will increase. And they say black holes have a lot of entropy. From quantum gravity perspective, they inferred. And this is again a puzzle. How can we entropy? Because black holes is actually a single point from which nothing, no degrees of freedom is there. Then how can a lot of entropy? This is not explained. So now for the last 5 years, all the major problems, if you see Science magazine, Nature magazine, very discussions on physics portal, this discussion is coming. So even one Nobel laureate is there, Gerard T. Hoopt, he's a physics Nobel laureate. They are also in this game, and they try to put quantum mechanics ideas. So Tihub told that maybe on the black hole surface there is a brick wall, but by definition it's a vacuum. So they picturized that on the black hole surface inside information cannot be stored. Maybe on the surface some information is stored. There is no explanation. They just need it, and they assume it. And somebody told even black hole there is a brick wall, and it's a wall, it's a wall of fire. Firewall is there. So any observer coming there will be burnt into ashes. There is no explanation. They do some mathematical things, and then they interpret this thing without any basic interpretation. So what I did, so in one slide, you know various things, all these masses of the things, galaxies, stars, planets, they appear from a general relativistic solution called Schwarzschild solution, and actually I comes from a constant. That constant is actually parameter. If you take a galaxy, the value of the parameter must be very high, its mass must be very high. Then if you go to a star, that value would be large but still much smaller. And if you go to a planet, so constant is varying. If you go to a planet, it would be again number, but much smaller number. And what we showed that when you go to black hole is essentially a point, just a point there. Otherwise, all lots imagine it's come from a vacuum solution. We have shown exactly that for black hole, actually the point, the mass is actually zero. That means, and this radius of the sphere is proportional to the mass. There is no such arbitrary surface. They are all together. There is no event horizon. What I have shown, black hole is actually a point. That means your mathematical black hole, if it's a point, it has no called gravitational mass. Anything you see in the universe which mass cannot be exact black holes. They may be like black holes in many ways, many operational ways, but they are not true black holes. And this is shown by me, and before me also somebody had shown it, but that was overlooked. If black holes are not black holes, observed black holes, what they are? So here we worked on, there is actually series of papers on this thing, that whenever something collapses, it becomes hotter. As I was telling somebody, even if a balloon you suddenly compress it, air in the balloon will get heated. So when the stars are compressed, they are not only heated, they radiate. They have to, this is some basic law, even in classical physics it comes. They have to radiate and become hotter. So what we showed, that when a star is compressed, it may be becoming black hole. Immediately before becoming black hole, it is so, gravitation is so strong that it will trap most of the light and heat. And when lot of heat is trapped, it becomes extremely hot, and still some radiation comes out. And whatever radiation comes out, that exerts pressure on the incoming plasma. And that we have shown that a stationary state would be achieved when that pressure of the outward radiation will just balance the inward pull of the gravity, a quasi-static state. And this we called eternally collapsing object, that this is not a final solution, this is only a running solution. And it is a quasi-static, it is all the time evolving, maybe at infinitesimal slow rate. So eventually this red thing is tried to contract, but only asymptotically, and becomes a point, which is the actual black hole solution. But it takes infinite time. Like in LCR circuit, you have equilibrium actually after infinite time. So at a finite time, what we see are these balls of fire, and this is what I call eternally collapsing object. And they are also magnetized. Whenever in sun has magnetic field, most of the astrophysical bodies have magnetic field. And whenever astrophysical bodies are contracted, magnetic field increases, because of technical term is there, magnetic flux conservation. So we predicted that so-called astrophysical black holes are actually magnetospheric, eternally collapsing objects. Now this video. Now say sun is our nearest object, which is magnetospheric plasma. Now sun magnetic field is always restructured. Sometimes say magnetic fields are annihilated, north pole, south pole annihilated, and that creates a lot of energy. You have solar wind always. Then you have solar flare, then you have solar flare, and sometimes massive eruption. In fact, the eruption can be so strong, our communication system sometimes get disturbed. Lot of charged particles are blown out of Earth. They are called coronal mass ejection. This is just an animation of solar flare. Okay, same thing. Now we can go to the next thing. Next. Next. And this is one latest observation. This has become very big news. NASA's one telescope, NewStar, found that one of the black holes, some flare is coming out. Flares are seen always. But what made this important that this time this flare was triggered by a corona, that is burst of charged particles from very close to the black hole. This is cannot be explained. They cannot explain. And this can be explained when you consider that your so-called black hole is actually MECO, a ball of plasma, and there is a coronal mass ejection. And it is in this context Nature India had interviewed me in November, and then my news also spread worldwide. And this is something just this can happen in any field. Whenever you say something very strong truth, so people won't accept it, and that is very natural. And they can ridicule it, they can oppose it, but maybe ultimately truth trumps. And it has happened with many people. In plasma physics, Olfen is now considered a real pioneers of God. Olfen's theories were objected for almost 20 years, Hans Olfen. Then we know James Maxwell, that electromagnetism theory. He gave the theory in 1965. It was not easily, Maxwell was already well-known, respected physicist. Still, it was not accepted. Maxwell died in 1979. It was still not properly used. And only after his death, 10 years, the full importance was realized for Maxwell. I want to go through details of the list. I'll go to something that sometimes one has to think a loner. If you are on a rat race and joining others, teamwork is good in many kind of things, but most of the fundamental things do not come from teamwork. See, even if you see in this, you have this many important discoveries, or even the startups. So Snapdeal, somebody has found it may not have come from a teamwork. Maybe two persons lonely, they have been thinking. Suddenly they have come up, and they do right things. They things spread. Teamwork can give you only an average kind of thing. It cannot give you a breakthrough. And just on my work in 2000, many Americans, some American astrophysicists were working on it. And 2006, Center for Astrophysics, Harvard, had issued a press release. And I am not a person to boast about anything. I know that boasting is actually fooling yourself. But still, I would add, from Indian science, lot of things are done. But very rarely something done is India. And that is become a content of press release from Harvard, extremely rare, and maybe this is the only time it has happened. So when you do abroad with the others, then there could be press release together. But just homegrown thing, Deshi research, and that people are working, and that on that there is a Harvard press release is extremely rare. And so one has to think in a new way. So one can earn a lot of money, one can have a lot of knowledge. And India has the biggest pool. Here I am sitting in one of the biggest maybe pool of talent in India. And we do a lot of research. And we do technology advancement is there. But our innovation quotient is still not satisfactory. And India comes quite low in the some global innovation index. I do not know on what basis they do make it. And this is the number of patents. Number of patents, India comes almost nowhere international. So we talk of technology, many institute directors will come technology. We do technology, but technology has to be useful and people are ready to buy it, that kind of innovations. Maybe now it will start. New government is very keen for Make in India. And one Nobel laureate came, David Gross. He said that Make in India will not be fully successful unless you have research in India and innovate in India. So this is a bright pool of scientists, maybe future bright pool of technocrats and technologists. So they should think, and many students that think, try to think in original way. There will be hurdle and try to overcome the hurdles. And this is some of the innovations. For innovations, one need not be very great. Even one need not be IITian or any engineers. These are some of the innovations done by poor Indians in a rural side, rural fridge. This is a simple thing, we may laugh at it, how to climb a tree. Somebody has made a contraption. It is a very important innovation. And this is in the rural area, you need Assam and Northeast lot of how to split the bamboo to make houses and doors. This is a machine for bamboo splitter somebody has developed. And this is a portable ultrasound machine, again somebody has developed from India. And you know, these Gujaratis are very innovative, so somebody is using it, Mumbai as a tractor. Here, we know biogas plant is there. No, in the normal condition, they take a lot of time. So here, how to make the biogas fast and also channelize it. This is done by an engineer, an humble engineer. This is two rural boys have made their homemade windmill, and they are using it for pumping water. And this is only a bicycle. It has been used for cultivate in the field for some purpose, for plowing and weeder, actually to remove the weeds, extract the weeds. This is Maharashtra. And this kind of machines, harvest reapers, are available in the West. India, they are not used. Mostly market may not be there, but somebody has developed it at low cost. And this is not innovation, this is kind of startup. In Tamil Nadu, somebody has set up some hospital for heart treatment, and very low cost. So this kind of startup also one can think. So we have here engineers, many of them would be technocrats and startups. And if ordinary rural engineers can do so much things, so what an IITians can do? So they can do wonders, and then India can be one of the most innovative countries. Actually, India needs a lot of technology. The fact is that despite IITs and other things, we import most of the technologies. In our defense sector, we import 65% of the things. DRDO is working, but many of the, even we do not make a good, say, rifle. And many of the things, say, in the ISRO is using cryogenic engines. But most of these things we got from Russia. And only one now India cryogenic engine has made, and that has been successful after many failures. But India has huge talent pool. When Indians go abroad, they become CEO of top companies. They are doing a lot of innovations. And we need to think why within India we cannot do this thing. I do not blame anybody. So partly it is our educational system, and this you are in a rat race, you do IIT and then you go for a big package. But this year Mumbai University, Mumbai IIT, I was reading many, at least 3-4 IITians who have got very good fat packages, several crores of rupees abroad have rejected, and they have decided to come in India, work in India. And India, there are problems because in many companies the ethos, the working norms are not suitable. So maybe if talented, ambitious person join them, they find a lot of difficulty. So one can go abroad, but at the same time, like India is our mother. So mother may have many drawbacks, but ultimately it is our mother, and we need to think even if we are abroad. We need to think. IITians do that, others. All our this they remit lot of money, which helps the economy. They are producing lot of jobs. In fact, Indians are one of the biggest job creators in America. So Indian technology sector, other sectors, but something much more would be done in India. This is not left to the students. This is whatever the science managers, the governments, they are there. So I look forward to a stage when the government will evolve, and IITians, even if we should be proud that we have a degree in India. Somebody has done a postdoc within India, still he is getting a job in India. We do not look permanently to the west or something, to a foreign level is there, only then you are good. This mindset should go. We are biggest pool of talents, and we should be proud Indians and proud IITians. Thank you very much.
Thank you so much, Dr. Abhas Mitra. I think it has been a wonderful talk, very inspiring, very thought-provoking, and as he has said, never stop questioning even the most established scientific theories, but even in order to do that, you have to have solid scientific background as well. It has to be very, very scientifically questioned if you want to question established scientific theories. Um, uh, with this, I just want to request all the audience or a couple of young minds particularly, if you have any queries, you please go ahead. We don't have much time although, but he will certainly be accepting a few questions from the audience, particularly from the kids or young minds. Okay, please go ahead. Sir, sir, you come here, otherwise they won't be able to. Yeah,
Please.
do you have any microphone over there? Yeah.
No questions, no?
No, no, no. I
Okay.
think they are just getting the mic. Yes. Just speak on the microphone, otherwise it won't be audible.
Sir, you had shown the image of corona burst from black hole.
Yes.
These are gamma radiations or visible light?
This eventual flare was seen in X-rays.
Okay.
Flare was seen in X-rays, but
Huh.
it was triggered by a eruption of corona, that is charged particles, from close to the black hole. That is the interpretation.
Good morning, sir. Uh, I have heard about gravity telescopes. Can you tell me what are they?
Could, could you repeat it?
I have heard about gravity telescopes.
Gravity less.
Gravity telescopes.
Telescope.
No, 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 no. You may be talking of this gravitational wave detection telescopes.
Yeah, yeah, something.
Yes, they are actually laser interferometers with very long arms, and there are some metal bars are there. If there would be some little change in the length, arm's length, then laser interferometer over hundreds of kilometers will get some pattern. And but so far nothing has been detected. Gravitational waves.
Thank you.
Hello, sir. You talked about a true black hole,
Yes.
and you said that its mass is equal to 0.
Yes.
So what is the difference between that state and say a vacuum where there is nothing?
What is the difference between?
A true black hole.
Okay.
And
So true black hole is a singularity. Real singularity, infinite gravity, infinite density, from which really nothing can emerge. But what we are telling, what we astronomers are seeing are actually almost black holes, that there is also a very strong gravitational field, but not infinite field. So light and matter can still escape. They can still escape, but they will appear like black holes because they are also very strong gravity. So light is your redshifted and diminished in intensity, but still something can emerge. That's all.
True black holes do not exist.
Do not. And actual this thing, something can emerge. Their gravity is extremely strong, but still finite, not infinite.
Sir, someone from Kolkata said that black holes don't exist. Yes, sir, and it has been proved also.
That is exactly. I think you are standing in front of him.
Oh,
You saw this news on the paper.
yes, sir.
You came across this news, and
Yes, sir.
you.
Sir, do black holes actually exist?
See, by black holes, actually astronomers means very massive compact objects. They do exist. But all that we told that they are almost black holes, but not mathematically the way they are defined. So their gravity is extremely strong, but not infinitely strong.
Sir, why true vacuum does not exist?
I have already discussed this thing that there is something when things are compressed, it becomes very hot. And when hot comes to a stage, when the radiation pressure is just counteracting the gravity, so a quasi-static state is formed. And this continues for indefinite time, and it will take indefinite time to they lose energy and lose mass, and so it takes indefinite time. So that is why the so-called whatever we are observing, I and now many feel that they are only almost black holes, not mathematical point black holes.
Thank you, sir.
Welcome.
Good morning, sir.
Morning.
Sir, what exactly is antimatter? We have heard of antimatter bombs in novels and movies, but what exactly is
No,
antimatter?
antimatter is known. There's actually antimatter produced in lab. It is called positron. Electron has antimatter. Anti-electron has some quantum numbers. Their charge is there, and some lepton number is there. For antimatter, those things will be negative, opposite. Say electron's charge is minus. So antimatter's charge would be positive. Exactly opposite quantum numbers, antimatter.
Sir, has natural antimatter been discovered?
Yes, positrons are first discovered in cosmic rays, then they are produced in laboratory also, antimatters.
Sir, has it been...
Antiprotons are discovered in laboratory.
Sir, have Indian laboratories found antimatter or made them?
Yes, yes, some of the accelerators, no, big accelerators are not there. They are done abroad, but in collision it is common to get antiproton or even a positron.
Thank you, sir.
Yes.
Good morning, sir. Can you tell me about the thing which is in Bermuda Triangle?
Pardon?
Can you tell me what is there in Bermuda Triangle?
No, 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 no. That is actually I never work on speculation or talk. I do not know whether it is real or not. I do not have idea. Sorry.
Thanks.
See what I wrote in 1998. There is neither any black hole nor any Hawking radiation, and nothing has been discovered. Actually, I am originally gamma ray astronomer. There was a prediction small black holes will burst and give lot of Hawking radiation. Nothing has been found in 40 years by gamma ray astronomy, and there are theories why Hawking radiation should not be there also. And in case is very simple. Physically, they explain say black hole is there. Even if you assume a black hole, there is positron electron sign kind of say virtual pairs are produced. They say whatever is positively mass, it will go outside and that will be seen as Hawking radiation. And negative things will fall within the black hole. But this concept is wrong because gravity will affect both positive and negative. So positive and negative both have equal chance of falling inside the black hole and going outside the black holes. So from this thing also there should not be any Hawking radiation. And then if my proof is correct, there is no black hole also. So question of Hawking radiation, black hole information paradox from which we keep on hearing regularly, nothing exists. These are all fictions then. So you are disturbed, you had some other...
Good morning, sir. Sir, I have a question about relativity. What are your opinion about relativity, time dilation?
What?
Means, do you believe in time dilation? Time dilation, sir, relativity.
Time dilation. Okay, time dilation, different observers see the time in a different way. So in that happens in special theory of relativity also. Special theory relativity, suppose cosmic rays are coming and they have a lifetime. It has been actually discovered. Say muons are coming, they are decaying. So in their rest frame they will have some time, but observer rest frame they will have much different time, much longer time. So time is relative to each observer. So whatever I am, my clock is showing some time. So if I move in a jet plane with a velocity, suppose extremely large, then that time interval will be different. So every observer has his time scales.
Good morning, sir. So this is something about inflation cosmology and multiverse is going on abroad. America is doing some research in MIT with Professor Alan Guth is doing. So actually, I want, can you throw some insights about what is inflation cosmology or how this multiverse they are trying to prove? And
Big Bang Cosmology?
Yes, sir.
So Big Bang Cosmology says
like before
universe.
Big Bang they are telling, like inflation cosmology, like before what exactly happened
Yes.
before Big Bang, like that.
See, these things cannot be discussed here, but you have already read, so that is why you are talking about it. So Big Bang says the universe was burst out of a singularity. There was nothing was there. Then universe erupted out of nowhere. In many fields, say in earlier fields and many fields, this is actually unscientific. Because if nothing was there, not even time, space was there, where from it came? I do not believe in Big Bang cosmology. In fact, I have been working a lot in cosmology also, but I do not want to talk. Many feel Big Bang cosmology is incomplete and incorrect. And inflation also, actually, I have two papers in 2014 also. And the title of the paper published in New Astronomy, Why No Inflation? And that was one of the most downloaded paper from New Astronomy in 2014. But we cannot discuss the technical things here. Thank you. Morning.
Good morning, sir. Sir, as you said that if black holes are not there, so around which all the galaxies surrounding?
Around?
If black holes are not there, is not there in the galaxy, at the center of the galaxy, so what is that actually? Around
so I
which?
am telling, no, they are balls of fire like sun, but much more compact. So what we are selling, because this was the NASA observation. So NASA observation that is interpreted in press release, you can see. It is telling some X-ray flare has been seen. That is fine. But what made this a big news that it seems to be triggered by a burst of charged particles from somewhere close to the black holes. Now from black holes nothing can come out. On the other hand, what we have shown that so-called black holes are actually balls of fire, balls of plasma. There could be bursts like from sun you have burst.
Sir, how can we detect a black hole?
Pardon?
How can we detect a black hole?
Okay. Black hole. See, this is a complex thing, and then actually one see if they are in a binary star. Mostly of this black holes sometimes are in binary star. So by studying the period, Kepler's law is there. One can obtain something like mass function. This is technical thing. You can find mass function. If one companion mass is known, then one can find the other mass. So this is called out of the mass function, mostly in binary. If it is isolated, it is very difficult. There are very indirect ways.
Morning, sir.
Morning.
First off, let me say the presentation was wonderful, and I am from a civil engineering side. I'm a research scholar from traffic engineering, and for a person who knows nothing about black holes, it was very informative and it was very crisp, and I actually understood, which was surprising for me. What really I wanted to ask was not exactly related to black holes, but I understand that during the course of you trying to publish the paper, there was, I believe, a lot of difficulties because this was a very novel idea at that time, and I think the scientific community...
Yes, that is a big story. Now I will write actually my autobiography and some other books also. In fact, I have superannuated from BRC. So there are a lot of, I think I did not even explore for jobs. The Roorkee IIT had recruiting, Guwahati IIT recruiting, Gandhinagar IIT. Had I applied, maybe I would have got 5-year contractual position. But I did not want to actually teach. I wanted to do research and write books. There is extreme difficulty, and partly things are discussed. See, if you have somebody has snatched your murdered you can go to a law court. Even a minister has done. But a referee says, I do not believe in this paper. Nothing doing, editor will reject it. And this happens out of, say, in such a cases, out of 10 referees, 9 referees will say no. And even Nobel laureates, they have faced discrimination. One Nobel laureate is Brian Josephson. Brian Josephson is condensed matter physics Nobel laureate. So even he is banned from some of the sites, some Cornell University preprint archive. So these are different things. There is lot of corporatization and lot of politics. Big science is big politics actually. You have to get billions of dollars, lots of millions of dollars of money. You have to keep your ego high, prestige high, convince the politicians, and then this journalists work in tandem, and then editors are out of this thing. These authors, mainstream authors who make their establishment. 99 referees should be those things. So they become extremely difficult, makes life 1,000 times more difficult, which I have had. But those things I will write in my autobiographies. Thank you. Incidentally, but my things are, most of the things I talk only on when they are published. So, and on the black hole related thing, there are almost 27 peer reviewed papers by me and my American colleagues and other colleagues.
So,
and book chapters and in some invited talks.
So what are your views regarding the education system in India with respect to scientific research, especially in colleges?
Repeat please.
What are your views regarding the
scientific? See, India, I said India is a big pool of talent. See, IITians go, even average engineers go, they do very well in USA and other places. So somehow our culture, and which I feel, I think he's my this very respected academician is there. He has got very good job. But with the same talent, had his all these postdocs been in India, he might not have got in IITs. It is this mindset that we do not have deep self-respect. Before independence, some Satyen Bose in Dhaka college doing, she had confidence, she could write to Einstein, Einstein said it is correct. But those days have completely changed, it is all corporatization. And Indians' mindset is there, unless foreign level is there, no recruitment anywhere. That means we do not value our own things. And when you do not value your own country, your country cannot excel. So I would stop there. Maybe I would write more. People do write about it. And there is always, he works in applied things slightly, it is, but in basic sciences, it is controlled by somebody, Harvard, Cornell, some people. So you have to keep them in good humor. And unless you have a big mentor abroad, you cannot go to conferences, publishers. So then you cannot think originally. So you have to be mostly followers. So we have become mostly followers. Thank you.
Thank you.
Hello, sir. Objects with heavy mass usually bend the space-time fabric, and we can also that's how we envision gravity, and we can also envision wormholes by connecting 2 points in the space-time fabric. So how do we visualize a black hole on space-time fabric? And moreover, all the particles and materials which enter the black hole, are they really going into an parallel universe, or are they creating some new kind of subatomic particles, or what is actually happening inside the black hole?
Okay, your question is very long. I have understood part of it. But they say parallel universe. In fact, the concept of their concept of now multi-universe, parallel universe, they partly came from the black hole. Because as I told, now somebody is falling into the black hole. Actually, at the center, even at the event horizon, it has a speed of light. When you would go to the singularity, it is actually speed of infinity, at infinite speed. Then it cannot stop there, because momentum conservation is there. And nothing can come out. Either it has to bounce, or some damage has to be done. No, singularity, you cannot do any damage. So then this black hole paradigm is now 100-year-old. There is no answer to such questions. So some people tell he goes to somewhere else. It becomes a white hole in another universe. So white hole is opposite of black hole. You see burst of energy coming out, something like a Big Bang mini, out of nothingness. Again, nothing has been found. But many people have worked, many people have earlier they used to work. And some say it goes to another universe. Some says in the black hole throat there is a wormhole, it goes to another universe. I showed a picture sometime that this kind of picture is there. Is it there, the slide? No, maybe it is there. Here. So somebody is falling, this is called wormhole, emerging somewhere. These are all pure speculations. There could be some mathematics. Mathematics, if a theory is there, one can have a lot of mathematics, any kind. Mathematics is not physics, and no experimental evidence, and these things are not clear. All these confusions can be cleared, but what I have told, that black holes are never formed, exact black holes. They try to form at infinite time asymptotically, never formed. So you don't have any such problems. So no parallel universe.
So how do we visualize a black hole on the space-time fabric? Is it
how do we recognize a black hole and
on the space-time fabric?
Space-time carving.
Yeah.
Space-time carving is nothing. Even this is carving its space-time, but with little amount. Space-time carving is, that is, he told no time dilation is there. So space-time is an abstract thing. 3 spatial dimension and time, special relativity is there. So we can combine them in a mathematical framework that is called a space-time. So relativity also same thing. It does not mean any physical kind of membrane is there. So even if his little gravity, so time is little carved, you can say time is elongated here. So black hole also has, any object has, any planet also has space-time curved. In fact, relativity also has confirmed because of space-time warping. Because light rays were bent during eclipse around sun, not around the black hole, then that was measured, and that agreed with Einstein's prediction, general theory of relativity. So it has got nothing to do with black hole, with any object. There is space-time curving, any object with its gravity.
Thank you.
The last.
Okay, we'll be taking only one more question. Please go ahead.
Good morning, sir.
Morning.
So we know that everything that exists or taken or has taken birth has to die. So will ours that is present in our galaxy will not die ever?
Sorry, I could not follow you.
Sir, we know that a black hole exists in our galaxy.
So black hole or whatever black hole candidate day exists. In fact, what I tell, that whatever you are telling black hole, there is, it can absorb matter and matter can come out. So in the universe everything is evolving, and so I tell that even black holes can dissipate. Because there is burst from black holes, something black holes can also, matter can come out of black holes.
Sir, they don't die?
See, you do not know. In a classically, black hole live indefinitely. They can only absorb and can become fatter and fatter, classical. And as per Hawking radiation, black hole can die if Hawking thinks. But even without Hawking thing, what I am telling, black hole like sun will die one day. Because there is no event horizon, things can come out. So black hole can only die and dissipate. In fact, what I feel, universe, everything is evolving. Stars are born and die. Galaxies, I know, they are born and die. They dissipate, they form gas, new galaxies are born. Similarly, black holes can also die, and because of evaporation and other things coming out. And again, new gas will be there, again new things will be produced, new star, new black holes. Everything is getting recycled in the universe.